are going from the force, we are going to obtain the potential energy. To obtain that, we write again the work from going to A to V. We already found it is KQQ, 1 divided by RA minus 1 divided by RAB. This is the work done from A to V. Okay, the work done from the infinity, so the point A is the infinity to the point V. The point V is the point where it's a certain distance from the charge capital Q. The work here is if the initial point RA is the infinity, 1 over the infinity will be 0, so the work will be this, minus KQQ divided by RB. If we place, if we put RB like R, so then the work can be writing like this. Can be writing, instead of this, can be writing like this. You put it like this, minus KQQ divided by R, where R is the final point, this is the R, from the charge Q. So you take the charge from the infinity, you place it here at a distance R from the charge Q, and this is the work done. But the work done is equal to the minus variation of the potential energy. The work done has made by the force, the electrical force, and the electrical force has done a work and has pulling up some energy from the field. So the work is the minus the variation of the potential energy, so I will write minus the variation of the potential energy final minus initial final, B or R minus initial. So the work done is the work from going from the infinity to at point B, that is the point that I call R, the point that is a distant R. The work from the infinity is minus KQQ divided by R, and this is minus the variation of the potential energy, but minus the variation of the potential energy is the final E sub P of R minus initial E sub P of A. But E sub P of A initial is E sub P at the infinity. So we have like this. We have that minus the work done is minus KQQ divided by R equal E sub P initial minus final. So we take E sub P initial, the initial point at the infinity, like the reference point of the potential where we measure the potential, and we say that the potential at this point is 0. So this would be a 0, and the equation that we will have is minus KQQ divided by R. It will be minus E sub P at the point R, at the final point. So the function that describes the work, that take track of the work, is the function E sub P of R, KQQ divided by R, where R is the separation between the charge, capital Q, and the distance where you put the little q from the charge, capital Q. So, conclusion. If you have this force, F, minus KQ, the potential energy associated to this force is this potential energy. And from this potential energy, in the case that Q multiplied by Q is positive, so it means two charges that have interaction that is repulsive, so the potential energy makes like this. Is meaning that when you are at certain distance R, the potential energy is like this. When you go further, the potential energy decreases. Now, if the Q by Q is negative, if Q multiplied by Q is negative, this function, the potential energy, is represented by the graph that I have draw here, this graph. And this graph say that at any point, let's say this point, the potential is like this. When you go and you increase the R, this is the R, when you go increase the R, the E sub P increase. So this is the feature things that you have to see clearly for the potential energy.